Hello and top of the morning to you, or whatever part of the day it is when you're watching this. Today is St. Patrick's Day and I have gone looking for a puzzle that reflects that and have a field full of shamrocks to deal with shortly, so looking forward to that. Now, before we get to that, I want to mention our apps, of course. They're available on the links within the description field, and of course so is Patreon, our Patreon site, where so many people, we've gone over 4,000 patrons. Thank you very much to you all, and they include these 5 who have also solved the new 7 wonders of the world Sudoku hunt, so we're still getting answers in on that 16 days into it. Very many congratulations for each of those people. This represented a lot of effort and well done. The hunt is very popular. 7 puzzles for you to try and a final wrap-up one, and then deducing the required word. Very many congratulations to those. Now, there's other stuff on Patreon, of course, as well, including yesterday my speed run of 6 times crosswords, a week's worth that I was attempting to get done in 36 minutes. You can see how well that went if you want. Now, this puzzle is from Gruckles, who I thought we had featured before, but I don't think we have in the end, so my mistake there. But anyway, look at this. This was posted to our Discord server back in January, I think, but couldn't be more appropriate for St. Patrick's Day. It is called Shamrocks. It does look like a bunch of them, and it is basically a thermo Sudoku, but with a twist. So normal Sudoku rules apply, normal thermo Sudoku rules apply, which means that on these green thermos, numbers ascend starting from bulbs until they get to ends. So most of these obviously have 3 bulbs, or leaves, I suppose they are in this case. And they must contain a smaller number than this one in this shamrock, and that must be smaller than this number. So however many this arrangement is a 4-leafed shamrock extra lucky, I don't know, but this arrangement means that all of those must be smaller than this digit, which therefore must be at least 5, for instance. And there is an extra twist, as I say. That is the disjoint subset rule, which means that for each position within a 3x3 box, each of the digits occupies it once in the puzzle. Now, the simpler way to express that is perhaps to say that no identical digit can be in the same position in 2 3x3 boxes. So because we have a 1 there, we cannot have a 1 in any of those positions because they are in the bottom left of a 3x3 box. So that's the rule. It really does increase the difficulty of scanning the puzzle when you do get some digits in the grid. So watch out for it. It's a bit of a beast to play with, but I'm prepared to take it on. And do so likewise, if you will, on the link under the video. I'm going to start now. Let's get cracking. And I know full well that Simon would expect me to get cracking by filling in all the possibilities along each thermo. And I am not going to do that, you'll be surprised to hear, because that would just leave us with a huge busy grid full of pencil marks. So I'm going to have to do the more Simon-esque thing of looking for interesting... Well, we've got 2 boxes, which are 3 boxes, I think, which are entirely full of thermos. Every cell is on a thermo in some way. And look, in this central box, where can 9 go? That's the first question. 9 can never be, can only be on the end of a thermo, and there is only one end of a thermo there. It's got to be on that cell. Every other cell is on a thermo and not the end, so 9 has to be there. Now, what can we do with that? I think what I'm going to do, I'm going to take it that 9 is a good place to start. Having spotted that, I'm going to highlight other cells in other boxes that can be 9. They're quite easy to spot using this knowledge bomb about ends of thermos, or not on a thermo. And they get quite interesting up at the top. Okay, I've almost run out of places where, yeah, where can 9 be in row 3? That's the question I should have asked, because I don't think it can be anywhere except in this cell. Yeah, I'm definitely right. So 9 goes in there. Actually, I will keep colouring because I'd like to see the pattern of 9s now. Up here, oh, it's got to be in the top row in box 1. That's perfect. That takes it out of 2 of the 3 possibilities in box 3, and we can put 9 in the remaining one. So that's not a 9. Now, okay, that is no longer possible because of where 9 is appearing. And in this box, it now has to be in the bottom row. That rules out all of those, and we can place 9 there. Excellent. So this is the only place remaining for 9 in row 6 now. That can't be a 9. Oh, can't sort out that X-wing up there, but I can sort out all of the remaining places. 9s have to be in these cells, and that's most of the 9s placed. Now up here I'm going to put the corner mark. I know that these are the only remaining cells that can be a 9. I actually think 9s are much more likely to be on that angle where they are forced to the ends of these thermometers than on that diagonal, but that's not logic, that's just instinct. So 1s, if you look at this 1, that's now ruled out of these bulbs. 1, like 9, 1 has a special feature that if it's on a thermo, it's always on a bulb. But that doesn't take us very far. Yeah, I mean 9's very different from 1's because there's so few ends of thermos relative to how many bulbs there are in this puzzle. That is one of the features of a field of shamrocks, I suppose. Okay, so 9's not so... 9's we're kind of done with. 1's not so good. Let's have a look at 8's. Yeah, there's only 2 positions 8 can be in the central box. Oh, and one of those it can't be in at all anymore, because in this position, an 8 there would need a 9 here, and that clearly can't be a 9. So in fact, we can write in 8 in the central box there. Let's choose a different... Well, I don't know, what shall I do? Get rid of the colouring for 9's? Yes, I will. Let's choose a different colour for 8's anyway. This is the only cell for an 8 in box 6 now. It can't be there because that would have to be a 9, and it can't be there because of the 8 there. So I think it has to be in the centre of this shamrock, and that means we can place 8 here. So that's a good start. I hope I'm not missing something there. It feels a bit odd, but okay. That can be 8, and so can both of those. Again, it's got to be confined to those two. Yes, it can't be here because that can't be a 9 because of that 9. So 8 in the top row is one of those. It can't be in that cell. And now 8 in row 3 has to be here, does it? I think it does. Yeah, I think it definitely does. And that puts a 9 here. So my prediction for once was correct about where the 9s would be. Proved already. Let's colour that one in. Don't know about those. Now, these can't be 8. So 8 in the bottom box and on the box 7 is there. Those are possible, I think, in box 8. But this is, and this is in box 9, I reckon. And don't forget the disjoint subset rule, like I have been doing. I haven't even thought about that yet. Now, maybe it doesn't actually matter. One of those is going to use the right-hand side. sort of the right hand middle cell. Oh, I don't know. I'm not sure how to resolve this. Can I do it just as it is? It's so hard to think about the disjoints. We've used bottom left. We've used middle. Oh, those are all the bottom ones. So these ones, there must be a central row one there. That's center left, so that can't be an 8. Gosh, it takes some time to spot these for me. Right, 8 there, 8 there, 8 there, and 8 there. And I think we are done with 8s. Let's get rid of the colouring. Yeah, I think we are. Let's just highlight the 8s and make sure they seem to be obeying the disjoint subset rule as well. Yeah, it's a useful check actually, but I think they are. Now, can we move on to 7s? That really is the obvious next question now. The trouble is, there's quite a lot of places 7s can go. Let's see, I mean, all of those could be a 7 as far as I can see in box 1. And in box 2, it's almost worse. Maybe I should be starting in box 5. In fact, it is every cell could be a 7 in box 2. So I think I've started in... Oh, it's very different in box 3, though. That can be a 7. This one can't, because that has to be higher. I don't think anything on this shamrock can be a 7, because you'd need a higher number at the end. Yes, okay, that is better in terms of restriction. Now here, there's quite a few possibilities in box 5. That isn't a great place. Only 2 in box 4. It's really weird how this plays out. Those could, either of them could be a 7 and that, but only that on the right hand shamrock. Does that mean that we've only got left with one place for a 7 in row 6? Yes, it can't be either of those because that has to be higher. Can't be there or there. Yes, actually it's quite straightforward. We might get more out of that. This can't be a 6 because you just can't go to the end of it then. And these can't be 6s either. So 6 is on one side of that 7, which is possibly not the most helpful thing. Anyway, carry on with 7s. Right, now we've got a 7 there. All these can be uncoloured, and these two in the same box. Now we can... this is a great thermo, because 7 has to either be on the end or not on it. That could be 7 or that. Oh, and that's all in box 8. Oh, I should have started looking at 7s down at the bottom. Okay, it's lucky we started there and there, because now 7 in row 7 has to be in one. It can't be in that cell. It could be there or there. So I think I've got all the positions for 7 marked. Trying to remember the disjoint subset rule doesn't matter yet. Where have we got any patterns here? Look, one of those two is a 7, and it's in the central cell of a 3x3 box. So that means that is not a 7 and that is not a 7. So they can be uncoloured. And now we know where 7 is in box 8. That is a really useful application. So then we can put it in up here too. Right, then we can uncolour a couple of cells as a result. Now we know it's in the middle right here, so that's not a 7. It's in the middle bottom here. That's really helpful in this box. That's not a 7. So now we can place it there and there and there and in box 3 and everywhere. And I think those are all the 7s. And now I can uncolour blue. Now let's just highlight the 7s and see if they seem to be obeying. These are the 3 top ones on the right. Then the middle ones are there, there, and there, and the bottom ones, yeah, that's fine. They all obey. Now that got us the 1 done in box 6. That's the only bulb left that's not seen by that. So one of those two is a 1. I still don't think it's very profitable to look at 1s because there's so many bulbs around. So I'm going to have to take it down to 6s, I think, now, even though I've got this single pencil mark, which I could misinterpret as well. Yeah, I mean, let's colour for 6s again. Let's go back to purple now. I obviously don't want to use green, and yellow's a bit messy. Right, 6s. Let's start at the bottom. Let's start in beautiful box 7 with its beautiful 4-leaf lucky shamrock. We can put a 6 on the very end of it and a 5 there because there's just no other way they could fit in. Right. So 6 here is in one of those two cells. 6 here is next to it, the 8 somehow. Oh, look at this. Look at box 6. This one, that can't be less than 4 because it's got 3 smaller on it in its bulbs. So that's 5 or 6. But I think that has to be at least 4 because you have to have 2 numbers smaller than it there. So we end up with a 5-6 pair, and this is a 4. Good Lord, that's really weird how that's worked. 2-3 pair below it. And 4, 5, and 6 to go in the rest of the cells. So I'm slightly changing policy here, but let's go back to marking 6 potential. No, this can't be a 6 because there's a cell in between it and 7. That can be, and those can be. 6 up there has ruled it out of those cells. So then we've got a few here. That was a 6, so I'm just going to mark it. Then, yeah, there's quite a lot of possibility. 6 can't be on that thermo, so it must be in one of those two. And let's just complete the marking while we're doing it. There's quite a few cells there, but those two are looking at that, so that can come out. If that's 4, 5, this is 5 or 6, so I'm going to deviate from this. I'm not sure that this marking, oh, hang on, disjoint subset, yes. Look, 6 there means that can't be a 6. That's such a crazy rule that I keep forgetting. Anyway, that means this is the 6 in row 6. Now, disjoint subset again, maybe, anyone? No, can't use that, and that doesn't operate on any of the shaded cells. Right, I think it may be time to actually get pencil marking now. No, look, this 6, sorry, that's looking at those, so I can place a 6 here. That gets rid of that possibility. Now, bottom left, no use for the disjoint subset, no. One of these two is a central cell, and that's where it's got to be for column 5, but that doesn't affect any of the others. No, I'm going back to the pencil marking, I think. So these are from 1, 2, 3, 4. 6, not going to pencil mark there. What about down here? One of those is a 1, and the rest are from 2, 3, and 4. 4 has to be there. 5 has to be in one of these, and the others are from 2 and 3. So they're quite restricted sets. We've got a 4, 5 pair here. So yeah, 1 is in those, 6 is in those, and 2 and 3 are in any of them. What's this cell? It sees a 2 and a 5, so it is 4 or 6. You can't go lower than that because it has 3 cells that are lower than it below. Oh, that means the 2 is down here in one of these two, which doesn't help. Wow, nothing obvious is staring at me here. Or if, well, it may be staring at me, but I'm not staring at it. I don't want to pencil mark every cell in the top 3 boxes because they've all got so many possibilities. What is going on down here? Can that be a 4? Then it's 1, 2, 3 here. 6 there. No, it cannot be a 4. That's a great question. Right, if that was a 4, we'd have 1, 2, 3 here, 6, 5, and look, you'd have 5 and 4 looking up at a cell that has to be 5 or 4. So that's not happening. So that is the 6. Right, and that gives us a couple more 6s, definitely. Uncolour those. Now, how about the disjoint subset? Yes. Oh, well, that's just ordinary Sudoku actually takes that out. That from the disjoint subset can go. And we're left with a little X-wing of 6 possibilities. So I'm now going to take the colours. I want to take the colour purple out of the grid. Okay, I'm going to do it. There we go. Right. So 6s are effectively done. And this, okay, now this is a 5, and that makes this a 4. Those are 1, 2, 3, so this is a 5, 6 pair for definite. 7, 8, 9, these are from 1, 2, 3, 4. We're back to the pencil marking fun. 5 can't be there, so this is a 5. One of these is a 5. These are from 1, 2, 3, 4, but the middle one can't be a 2. Oh, that can't be 6, sorry, that's just simple elimination because of this 6. Right. 1, 3, or 4 there. That's 1, 2, 3, or 4. Obviously, no, it's not 4 because of that. One of these is a 4. We've got a 5 to put in row 3. It's got to be there. 1, 2, or 3 over here. We're not finished with 5s yet. We've got 1 to go in there and 1 to go in here. Well, those must be resolved by the disjoint subset somewhere. Yes, look, we've got a 5 there, so that can't be a 5. 5, that fixes our 6s as well. And all 6s and 5s are done now. Let's just have a look at the disjoint subset to check. Tops. Oh, there's 1 to go in here still. That is a 6 to finish off the 6s, sorry. And I've still got a 5 to put in there. All 5s done. 5, 5, that's the tops. The middle row, 5, 5, 5. And the bottom row, yes, okay, they look good too. Right, so we're down to 1, 2, 3, and 4 now. So I'm going to carry on filling in pencil marks because something might pop at some point here. Right, I think that's all the possibilities. I may be missing some elimination. Right, 2 in box 1. Can't be there. Has to be in one of those. Is not there. Can I do anything with these 4s and the disjoint subset at the moment? Yes, that can't be a 4 because of that. That can't be a 4 because of that and Sudoku. Oh, that can't be a 4 either because of that one. Oh, I do hate playing with this disjoint subset rule. It's so tricky to figure out. Maybe the givens. Look, that says this can't be a 1. Is it? It also says that one can't be. They've got a middle one here, so those can't be. And now I've got a 2-3 pair in box 3, so that's a 1. That's in the bottom right, so that can't be a 1. And that can't be by ordinary Sudoku, and that one. Piece by little piece. It is often how you have to go about this kind of puzzle, to be fair. Now, what else can we find? Let's go back to those 4s. I think I have actually used the disjoint subset stuff on all of them. Okay, let's have a look at middle cells, because we've got a 1, 8, 6, 9, 7, 5. So these 3 have to be 2, 3, and 4. So that can't be a 1. Yeah, that 1 should have operated on that. That's how I should have got that. What about bottom middle? 4, 9, 5, 7, 8, 6. Ah, and a 2, 3 pair. So this is a 1. That is a good question. Right, no 1 there. That's not a 1. Oh, is that all that's going to give me? Don't tell me that. Bottom right, 7, 6, 8, 9, 1, 4, 5, and another 2, 3 pair. Should I be colouring these 2 3s? Maybe I should. Because that, okay, let's colour them. That can be orange and is different from this. So that's blue, so that's orange. And that is different from this, so that's blue. Oh, it would be lovely if both of those blue and orange colours were looking at a single... Oh, that's orange, because that one's blue. Still, I can't... I want both of these colours to be looking at the same cell somewhere. And then I can rule out 2 or 3 from it. No, not quite there. I've got a single 2 and 3 there, but I don't know what colours they are, do I? If that is a 3, then there's a 3 there, but if that's a 3, then there's a 3 there. Yeah, it doesn't quite. I might be missing some. I think I've done the right thing, but I haven't worked out what it gives me. That's probably what's happened here. So let's just keep going. Maybe it's disjoint subset instead. Ooh, look, there's a 3-4 pair in top centers. And that makes this one a 1. Wow. Is that going to do it? Yes, that makes this a 3. And now we know that orange is 2 and blue is 3. And that was very useful. So let's uncolour those, both sets. Right, and now surely we've got enough to finish off. 4, 1, 2, 4. This has become 4. This is now 3 to finish the column. None of those have a 3. There is a 3 in one of those 2 cells, so that's not a 3. So the 3 in box 9 is there. This is a 4 to finish the box. That would have been the simpler way to do that. That's not a 1 anymore, so that is 2, 3 pairs all over the place now. Those can't be 2s. That's a 1, 4 place. Those can't be 2s. That can't be 4. So this is a quadruple that's as useless as a chocolate teapot, except of course for the disjoint subset. 1 there. That does fix this chocolate teapot triple completely. and that fixes the rest of the puzzle, and we are done. And that is very clever. And I consider myself indeed lucky to have been able to try that. That's good fun. Very well done to Gruckles for that, and well done to you if you solved that. I mean, I don't think it was easy, but I have to admit I am not brilliant at disjoint subsets, and I would fully expect a lot of the comments to reflect that. Thank you very much for watching, and hope to see you again soon on Cracking the Cryptic. Bye for now.